channel. So today we are solving an awesome algorithm problem, number of ways to assign 8 edge weights second, and this is from the Leetcode contest 157 weekly contest. This is Saturday and I have already uploaded Q1, Q2 and Q3. This is Q4. So let's understand. Just pause this video and go through the statement and then we'll go through. So let me read for you. There is an undirected tree with n nodes level from n to 1 to n nodes, and rooted at node 1 there is a tree represented by 2D integer array that is called edges of length n-1, where edges having elements, right? So edge at I having two nodes u and v, that indicates that there is an edge between u and v. Initially all edges have a weight 0. You must assign each edge weight of either 1 or 2. So the total cost of path between any two nodes u and v is the total weight of all the edges in the path connecting them, right? So the cost of a path between two nodes u and v is the total weight of all the edges in the path connecting them. Okay, you are given a 2D integer array queries. For each q queries at I, we have given u and v. We have to determine the number of ways to assign weight to edges in the path such that the cost of the path u and v is odd. If you remember, in this week I have already uploaded based on this pattern, right, where you have given the queries and you have to determine the number of ways to do something, right? So this is the similar kind of problem where we have given queries, and queries have some, you can say, elements, right? There can be 2D array or anything, right? So in these things we have the same type of pattern where we have given queries. So at each queries you have to determine the number of ways to assign the weights to the edges in the path such that the cost of the path between u and v is odd, right? We have to return an answer, right? The answer at I is the number of valid assignment for the queries at I. Since the answer may be large, you take a modulo for each answer at I, and for each query disregard all edges not in the path between u and v. Okay, so we'll see later more in the depth. Understand now the example here, right? So see, we are dealing with tree, path queries and bit magic, right? All the things are here. It is similar kind of problem that we have seen in this week, multiple times we have seen, right? Okay, so if you are doing the daily contest, you will understand these patterns, right? Now understand the example. Okay, we have given example 1 where similarly 1 and 2 we have given. This is same type of problem like previous problem we have. So examples are same, only the queries are different, right? We have added a new concept of queries, right? So as is 1 2, queries we have given 1 1 and 1 2. Output is 0 1. How? So queries as 1 1, right? As queries at I is 0, queries at 0 we have 1 1. So the path from node 1 to itself consists of no edge, right? So the cost is 0. Thus the number of valid assignment is 0. Okay, because this is giving queries 1 1 means itself, the node 1 having itself an edge. So that is not possible, right? Because if you are connecting by itself, right, there is no cost, right? It is not moving ahead. It doesn't have any edge. If there is no edge is there, means it is cost is 0, because there should be an edge, right? Each node will say that I have a edge, give me something, right? That is not possible. Okay, so queries at 1 2, the path from node 1 to node 2 consists of one edge 1 to 2. So there is one edge between 1 and 2 node, right? It is not about 1 and 1 itself having. 1 is not pointing to 1. It is pointing 1 to, right? So there should be an edge, right? There is an edge. So the path from 1 to node 2, node 1 to node 2 consists of an edge like this, and assigning weight 1 makes the cost odd while 2 makes it even. Thus the number of assignment is 1. So if the first query gives 0, second query is given 1, and so you have to return this. I hope you understand, right? Similarly, you can see, you can pause this video and you can go through the example too, and you will understand. So now you can think about the intuition. What could be the intuition is here, right? So we have given edge right? And each edge has two options. So for the path of k edges, right, there could be 2 to the power k assignment. Similarly, right, either you will have the cost 0, either you will make 1 or 2, right? What you want, the same type, right? But what we will take 2 to the power k assignment, right, in this case. So now here is the trick. Half of this will sum to odd and half to the even, right? Because either you will take 1 or 2, right? So if k is 0, answer will be 0. If k is greater than or equal to 1, means the answer will be 2 to the power k minus 1. All the odd sum combination will be there, right? And you will do the calculation and you will add all the assignments here. Okay, so I think let's try it on this one. Okay, so if you will try to understand this example, right, just think at, we have given these edges, right, 1 2 1 3 3 4 3 5, right, and coverage we have given 1 4 3 4 and 2 5, right. If you observe this example, right, you will find something here. What is there? We find the path length using LCA, the lowest common ancestor. Let's suppose from 1 for the path 1 to 4, right? What is the path is here? From 1 it will come to 3 and then it will come to 4, right? So the path length is what? How many? From 1 to 4 is 2. Here it will take 1 here and 1 here. So you will get the answer 2. Path length is 2, so here answer is 2. For the LCA 4, you can say 3 4. From 3 to 4 is 1. For 2 to 5, from 2 to 5, how many will be there? 1, 2 and 3, right? Means we find the path length using the LCA, lowest common ancestor, right? And the lowest common ancestor gives you the answer, exact answer. And so the output is 214, right? Because from 1 to 4, what is the lowest common ancestor? Is 2. From 3 to 4 is, we got 1, and from 2 to 5 we got 4. You understand, right? So if you understand the explanation and if you have the clear understanding of how we are going to find, just take a LCA, right, the lowest common ancestor, and you can implement it. There is another concept in the code. Let's understand the code, then you will understand the how we are going to do the DFS to build the depth and the parent, right? So we will use DFS and we will build depth and parent arrays, and then we'll do binary lifting. So we'll quickly find the LCA, right? So let's understand here. So as you can see here, right, what we need to do first, we have given these edges we have given and queries we have given. So first of all, we'll find the length, right, edges length. We'll create the graph, we'll assign it, and for all graph we will initialize its graph at I, so that we can build the graph, right? So these things we'll do easily. And now it's time to understand the DFS. Okay, so take the depth and there will be parent, right, like this you will define. So DFS will take DFS method will create from 1 to 0 and will fill the depth and its first parent. So let's first for 1 we'll take the DFS depth is 0, and then we'll do binary lifting, right? How we are going to do binary lifting? So first let's go through the DFS, right? So there is a DFS method is there where you will do you will define its distance, you can set the depth. So you go through this and you will understand that we are getting all the neighbors and we are checking. If not we have done, then we'll create one depth, increase its depth and go for the next depth, right? There is some helper function like we'll take LCA, right, and similarly we'll where was we here, and then we'll do the binary lifting. So for the binary lifting we'll take the loop, right? How we are going to do? For each query, we want to compute the path length via LCA, right? So for that, if you'll do the binary lifting, right, it becomes easy for each queries to compute the path length, right? So for that, you do the binary lifting, and you will have the here your parent. You will update all the parents here. Okay, I hope you understand, right? Or better, what I will do, I'll go through the, you can say, a deep dive, and we'll understand the code here, because the video will become lengthy, and the contest will be finished till now. Okay, so let me zoom out. I think contest is already finished, guys. Sorry, guys, but I'll upload you. You'll go through this, and I'll create a slide with this example, and we'll go through the code. Okay. So what are the things we have to do, right? First, let me tell you. So we'll do the binary lifting, right? And actually we will build the depth and its parent array, and then we'll do the binary lifting. So till there we have seen, right? We have done the binary lifting, and then we will compute these things, right? 2 to the power k minus 1 will do, and you will have the answer queries. Right? So answer queries will traverse for all the queries, and for all the queries at I and j, you will get the UNV, and you will find the through the LCA, right? You have the answer, right? So you can do what, once you LCA have, right, you just multiply 2 into its depth, right? You will get the 2 into depth, and you will add this, right? So you will get the total path length here. So just check if result at I equal to if the path length is 0, just assign 0, otherwise take the power of 2 and return it, and you will have the res finally here. So all these res will be keep assigned, so that you will return in the array form. Okay, so you understand, right? So first, what I have done, we have used that, we have assigned the DFS, we have used the DFS, and we have built the depth and parent. Then we have done the binary lifting, and then we have compute, you can say, through the LCA, right? Through the LCA, we have get the LCA, right? We have computed the path length via LCA, and then we have computed the answer, right? How we have computed, right? You know the formula, right? Power, you can take the 2 to the power path length minus 1 you will do, and you will get the answer that you will do here, right? So this is the LCA formula is there, and this. Okay, so I'll put this in the comment box, guys. You can get this code from the comment box. Okay, so that's it. Thank you for watching this video, and this is a little big problem, right? You can say hard problem, so I need to create a slide so you can understand it, right? So if you found this video helpful, drop a like, subscribe this channel, and please let me know in the comment box what do you like, right? And thank you for watching this, guys. Happy coding, and I'll put this code into the comment box. Thank you for watching this video.